This is Algebra 2, Lesson 1-5. Our topic is solving inequalities, and our objectives are to solve and graph inequalities, and to write and solve compound inequalities. So the first thing we need to know is when you're given a statement telling us inequalities on the left, what are the words that go along with and what are the graph? You read like sentence left to right, so we can see x, and then remember when your inequality opens to the right, it means is less than. So this is x is less than 2. And now when we graph that on our number line, when you make a number line, you have to have the number that's in your inequality, 2 on there, and then you really only need to have 1 above it and 1 below it to just show the progression of the number line. Remember that if there isn't a line under your inequality, it's an open circle, so it should be an open circle. And then if your variable comes first, you're gonna follow the direction that your inequality is pointing. X is less than 2, so we're talking about numbers like 1, 0, etc. So it's going to go to the left. And there's your basic one. Now x is greater than or equal to 5 is the next one. When we create our number line for that one, once again, our number line needs to have 5 on it, but then it really just needs to have a number above and a number below. Don't worry about putting 6 or 7 numbers on your number line unless you need to include more values. So we put a closed circle because it can be equal to, and it's going to go to the right. I want you to pause the video now and see if you can come up with the statements and the graphs for the next 3. All right, check your answers with mine. You should have x is greater than 3, x is less than or equal to -1, and x is less than or equal to 4. Now careful on this last one, before you graph it, my recommendation is that you always write the variable first. That way it's easy to tell which way to shade for your inequality. So I wrote it at 4 is greater than or equal to x is less than or equal to 4. Okay, all right, so on this one, the product of 7 and a number is more than 5. We're going to write inequality to represent this problem. I look for the inequality statement. That's your no more than. That tells you where your two sides of your inequality are. So the left side's the product of 7 and a number. Product means multiply, so it's just 7n. You can pick the variable. It doesn't have to be n. If they say number, I usually pick n because it's the first letter. And it's going to be no more than 50. So we know it's going to be something to 50. So the questions that I ask myself are, well, can it be 50? If it's no more than 50, is it possible for this product of 7 and a number to be 50? If it's no more than 50, that means it can be 50, but what it cannot be is 50.5 or 51. So it can be equal. So I know I'm going to have that bar underneath. Well, can it be 51? 51 is more than 50, so no, it can't. It can be 49 or 48 or 30 or 2. So whatever it is going to end up being less than 50. That tells you that you have a less than or equal to in there. What I'd like you to do now is pause the video and try the next two on your own and then check your work with mine. Alright, you can check your work with mine. I got n minus 5 greater than or equal to 12, and n over 3 is greater than or equal to 15. The one key thing when you're dealing with inequalities is we're going to actually take some inequalities and we're going to solve for the variables. So what we have to remember is that if you multiply or divide by a negative number, what you have to do is reverse the inequality. Anytime you multiply or divide, you have to by a negative number, you have to reverse the inequality. Don't forget this step. So here it says solving, graphing, and inequality. Solve the inequality and graph your final inequality. When you come to an inequality like this, there are many ways to go about solving it. The first thing I would do though in this one, 4 times the quantity x minus 7 is greater than -20. Rather than distribute that 4, I'm going to divide both sides by it. That leaves you with x minus 7 is greater than -5. Now notice I divided by a positive number, so my inequality is fine just the way it is. I keep solving, add 7, x is greater than 2. At no point did I multiply or divide by a negative number, so I don't have to worry about flipping the sign. Now I just have to graph. When you graph, like I said before, you need that number for your inequality, and then one above and one below. If you want to put more in there, you can, but really there's no need to. It's going to be greater than, that means it can't be equal to, so we're going to have an open circle, and it's going to point to the right. You have 2 more problems to do. Pause the video now and try the next 2 on your own. Alright, check your work with mine. You should end up with x is less than or equal to -8. Notice that from step 2 to step 3, I flipped that inequality sign because I divided by a -2. Same thing in the second problem, I ended up dividing by a -3 between step 2 and step 3, and so my inequality flipped and I ended up with x is less than or equal to 2. You can always double check your work by plugging in some number that satisfies your final inequality into the original inequality and see if it works. So for example, if x is less than or equal to 2 on this last one, if I plug a 1 in, I have -3 times 2 times 1 minus 5 plus 1. I need that to be greater than or equal to 4. 2 times 1 is 2. 2 minus 5 is -3. I have -3 times a -3 plus 1 greater than or equal to 4. 9 plus 1, is that greater than or equal to 4? Yes, in fact it is. It worked. The next thing we have to be able to do is be able to write an inequality given a situation. So here it says a movie rental company offers 2 subscription plans. You can pay $36 a month and rent as many movies as as desired. Or you can pay $15 a month and $1.50 to rent each movie. How many movies must you rent in a month for the first plan to cost less than the second plan? So the first plan is 36. So plan 1 is 36 bucks. Plan 2 is you pay 15 and $1.50 for each movie. So you have a straight up fee of 15 and $1.50 per movie. Let's maybe make MB movies. That's our variable. So we want the first plan to be less than the second plan. So we want $36 to be less than what that second plan ends up costing us. So we're going to put less than 15 plus 150M. And then we're going to solve for our M to figure out how much it needs to cost for us how many movies we need to rent for the first plan to cost less. So now we just start solving this inequality. Subtract 15, subtract 15. We get 21 is less than $1.50 M. Divide by all sides by a 1.5. And we get 14. So we end up with this inequality, 14 is less than M. We can switch that around to say M is greater than 14. Basically what it's saying is that if you want the first plan to cost less, you have to rent more than 14. You have to rent less than 14 movies. M is greater than or equal to 14 tells you that if you rent more than 14 movies, you are going to end up paying more for the second plan than you would for the first plan. So we need to interpret that. We would say you need to rent less than 14 movies for the first plan to be cheaper. Really, in this one, you could set up your inequality as a greater than to begin with, rather than a less than. You just have to know how to interpret your data when you get to the end. And in this case, I end up with an inequality M is greater than 14, which told me that in order for the second plan to cost more, I have to rent more than 14 movies. One quick thing we have to talk about is no solution or all real numbers as solutions. Sometimes inequalities have no solutions or all real numbers as solutions. And so here we have an example, one where let's solve it and figure out what we get. It says 9 minus x minus 5 is less than negative x plus 4. We just want to start solving for x. So combine your like terms on the left. Negative x, 9 minus 5 is positive 4, which is less than negative x plus 4. Get your x's on the same side and notice that the x's cancel. And you're left with 4 is less than 4, which I don't know about you, but 4 apples is not less than 4 apples. So we end up with this a false statement. And so if you end up with a false statement with no variables in it, and your integer statement isn't true, you're actually just going to say that this is never true. This has no solutions. So what I want you to do now is pause this video and this next one, and then let's see what you got for your last statement and discuss it. You end up with this statement, -2 is greater than 7, so we just have to think about that. Is that true? If you have -2, something is like greater than having 7 of it? No, it's not, so this is never true. Where you might end up with an always true statement is if you have something like 3 is less than 7. 3 is always less than 7. This would be always true. Where you might end up with something being sometimes true is if you end up with a statement like x is greater than 5. That is sometimes true. It obviously has a range of data where that would work. So this is your sometimes true example. And that was part A of lesson 1-5 for Algebra 2.